Welcome to Academic Digest class. So remember in our last class we did resolution of vectors, and we said that resolution of vectors actually ends up giving you x and y, and that when you have x and y, that this is right angle 90 degrees, and you can see that this is tail and this is tail. But today we are going to be treating parallelogram, and we use parallelogram when the angle between the vector is below 90 and above 90. So the principle of parallelogram, from the word parallel, it states that if you have a triangle that is below 90 or above 90, that by the time you use the principle of parallelogram, making sure that each side has an equal side. You can see that this side now, if I draw this, it should be equal to this side. Then this side that I'm seeing here will have an, should I say, a side to it as well. So you see, this is going to go and mean this. So this parallelogram method, we call it head and tail. You can see this is the head, this is the tail. So you can see then this one as well. So you can see, so, and notice that if that be the case, we say it's the principle of head and tail. So when I have this, so this is tail and tail, tail and tail. So the minute I want to get parallelogram, this change to this. So you can see head to tail, head, this is head to tail, head to tail, head to tail, head to tail. So parallelogram is called head to tail. Then it states, the principle states that by the time you get the sides, that where these two touch, that is where they are touching, becomes that you can get a diagonal line. So if I draw this diagonal line, you can see that this is the longer side. It seems longer than this one. That we can get the resultant using the diagonal. So that the adjacent sides of parallelogram can give us the resultant by joining where they intersect. So when I use this principle, using the same principle of parallelogram, you see that if I have a triangle like this, if I'm using the principle of parallelogram, I will now have head to tail, head to tail. Okay. This should be parallel to this, then this should be parallel to this. So let's do this one. So you can now see, if I join this side now, this will give me the resultant. So another thing you need to note that when we are doing resolution of vectors, we normally end up at the end of the day using r square equals to x square plus y square only. But once we are using parallelogram, let me draw this one. So I have two situations where I have an angle less than 90, and situation where I have an angle above 90. So so I have an angle above 90. Let's say this is this way. This should be parallel to this. Then I have this one. Then I have this going this way. So the principle is simple. So diagonal R. If you put your attention on the head to tail, you might get confused. So notice that this is tail, this is head. Then this is tail, tail. So extension of the triangular method. It's more like, if you want to consider it, you consider that the triangular method is always on the right hand side. That is when you have this and have this. Tail, tail. Then this side, head, tail, this way. Then so the principle, the key thing is to remember that parallelogram, when I have this, This part that seems longer is where I will get my resultant. The same thing with this. So I will always get my angle. The angle I will be using to solve will always be the angle facing the resultant, the diagonal. The angle I will always use to solve will always be the angle facing the resultant, the diagonal. So for that reason, let's say I'm giving a question. The minute I'm giving any question and I notice that the angle, once it's parallelogram I'm using, once I'm giving any question, notice that the angle I'm giving here, they will give me an angle. Let's say they give me this angle to be 30 degrees. And let's say they give me this angle to be 130 degrees. So the minute I'm giving any angle, then they tell me that there's a vector here. Let's say this is vector 5, this is vector 4. Then they tell me this is vector 5, this is vector 4. The minute I'm giving any question, if I see that the angle is less than 90, to find my resultant, I'll simply do r squared equals to, when it's less than 90. So when the angle given is less than 90, when less than 90 degrees, to find your resultant, simply do r squared equals to x squared plus y squared minus 2xy cos 180 minus theta. This is how you do it. The reason being that by the time you do 180 minus 30 degrees, you see that you're left with 150 degrees. And cos 150 degrees will give you a negative value. And by the time you times that negative value with 2xy, let's do it cos 150. Let's just point it and see. So by the time you do it, remember that when doing this, we actually derive parallelogram law using cosine rule. So when doing this, if I do cos 150, if I do cos 150, I have minus 0.8660. So notice that this is times minus 2xy. So you see that minus minus will give me plus 2xy times whatever this is. So times 0.8660 minus times minus. So you see that we now have x squared plus y squared equals to r squared. And this is looking like the formula for parallelogram. So cosine rule gives us minus here, but whenever you are doing the minus, you need to be paying attention to the angle. If the angle is less than 90, you do 180 minus that angle. So at the end of the day, you get this principle of cosine rule, which says that x squared plus y squared plus 2xy cos theta. Very important. So, but when the angle is above 90, if the angle is above 90 degrees, let's say in this case they give us 130, what I will simply do is r squared equals to x squared plus y squared minus 2xy cos theta. I'll just use theta. I will no longer do 180 minus theta again because the angle is already above 90. So cos theta here is simply cos 130. Any angle above 90, cos of it will be negative. So you see that by the time I do cos 130 will give me minus 0.6428. So if you times this, you see that minus times minus will give you a positive value of 2xy, whatever x and y is. If you put it now 0.6. So you see square plus x square then equals to r square. So very important to note. So once it's above 90, remember the principles we're using. And if you do this wrongly, you will not be able to get it well. So you have to remember this principle. Remember that whenever you use resolution of vector, to find your resultant, resolution of vector. And I told you that resolution of vector, the best way to do it is if I have this, any angle given to me, if it's on the vertical, I will ignore it. I will ignore it. I will only make the angle. Let's say, for example, they give me 30 here. I will not use this 30. I will say everything here is 90 degrees. So I will say 90 minus 30, 60 degrees. This is the angle I will use. So I will be using all the angles to the horizontal. That is shortcuts. This is a way for you to remember it. And as I'm using it, I'll be remembering the quadrant. I'll be remembering that this quadrant is minus, minus. This quadrant is plus, minus. This quadrant is plus, plus. This quadrant is plus, minus. So very important to remember. Very important to remember. So, and any answer you get from resolution of vector when you are finding resultant must be equal to whatever answer you get when you use parallelogram method. Parallelogram 1 sorry. Parallelogram, or you call it the cosine rule, or you call it the head-tail rule. Why resolution of vector is also called Pythagoras rule. And remember that once you use resolution of vector to find your resultants, to find your direction, you use tan theta equals to y over x. While whenever you use parallelogram to find your direction, you use sine theta over the opposite length is equals to sine alpha over the opposite length. Also, can also solve for the other one, the other angle, which is sine theta all over the opposite length is equals to sine beta over the opposite length. So this is what is. So this is what I mean. See what I mean? When you are finding the direction for parallelogram, see the angle you are looking for. For example, this angle. This angle. This is what you are looking for. You know that this side, everything this side is the same thing with everything this side. So that is why you normally see they can just draw something like this. So if I have this to be theta, this to be r, what is the angle between the resultant and the vector? Also, let's say this is alpha. Let's say this is beta. What is the angle between the resultant and the vector? Very important. So that is how you go about that. So let's try an example. So let's check out this question that we already have. So in this question, they gave us that a vector is on the, they gave us that a vector is having 4 here and having 5 Newton. 4 Newton on the x-axis and having 5 Newton. Then they now tell us that this vector is actually having 30 degrees angle. So at this junction, this is the triangle we are given. So what we just need to do if we see a question like this, so this is question, so example. So what we just need to do if we see this question is to ask ourselves, if this is a straight line, and I choose to redraw this, you will very well notice that everything I have here is looking exactly like another parallelogram. Everything I have here. Even if I choose to project this, okay, so I will now ask myself, if this is 30 degrees, angles on a straight line, let's say I project this now fully. Angles on a straight line is equals to 180. So 180 minus 30, that gives me this is 150 degrees. And notice that this angle here is looking like this angle here. So they are corresponding angles, 150 degrees. So, and remember that the rule of parallelogram states that the diagonal is what we use to find the resultant. And notice that diagonal is gotten by using the longest side, R, and if you are to use any angle, it must be the angle which is facing the resultant, which is 150 degrees. If you don't want to do this thing drawing like this, what you just need to remember is, since they give me 30 degrees, is it less than 90? Yes. That means if I want to solve, I will simply use this formula, which is 180 minus theta, which will still give you 150. Are you seeing it? But assuming they gave you just 150, assuming they gave you this angle in the question, you don't need to do it again. Just come and use this particular one, which is when it's above 90, just use that angle given. Alright, so let's try to solve this now. You now see that this will be the same thing as saying r square is equals to, let me do it here. R square is equals to x is 4, this side 4 square plus 5 square. In you will say this is not y, yes, but whenever we are doing cosine, it's only two sides we know. So if we put the other side for x, we use the other side for y. So minus 2 into 4 times 5, then cos. If we want to use 180 minus 30, to still give me 150, or we just use 150 because we've gotten it, whichever one you want to use, 50 degrees. So, and you know that because of 150, okay, yes, cos 150 will be minus 0.8660. Then 4 times 5 is 20. 4 times 5 is 20. 20 times 2 is, this is minus 40. And minus will be plus. So 40 times 0.8660. This will give you 34.64. So 5 square is 25. 4 square is 16. This will be 16 plus 25 plus 34.64. This will be 75.64 r square. If you take the square root of both sides, this will get out. So that you now have the square root of 75.64, which is approximately 8.6971 for r. Okay, which is equals to, sorry, and that means r is approximately 8.7, or you can round it up to approximately 9, and it's Newton. So r is equals to 9 Newton. R is equals to 9 Newton. Very important. So they can ask you what is the direction. So notice that this is what I now have. I now have it. So they can ask you what is the direction, or they say what is the angle between the vector and the resultant. So the angle between this vector, let me call it alpha. The angle between this one, let me call it beta. So you'll be able to find it. This is the formula you use. You say this sine theta. Remember I told you whenever you use parallelogram or cosine rule, always use sine rule to find your angle. So I'll say sine 150 degrees all over. The opposite length of this is 9, is equals to, then sine alpha The opposite length of this is 5 all over 5. Whatever, by the time I cross multiply and solve this, by the time I cross multiply, so by the time I cross multiply, I will now get 5 sine 150 is equals to 9 sine alpha, and this is going to be the same thing as saying 5 sine 150, this will be 2.5 is equals to 9 sine alpha. Divide both sides by 9. This 9 will get out. Notice I'm rushing it, so manage the handwriting. So now I'll be left with 2.5 divided by 9. I'm left with 0.2778 is equals to sine alpha. So to get this angle, I will say let sine cross equality sign. So alpha will be equals to sine inverse of 0.2778. So whatever you get is your answer. So I'm now with my calculator. So when you do it, whatever you get here is the angle. That is this answer. Is the angle that will be here in degrees. So now let's solve for this angle. To get this particular angle, what I'll simply do is the sine of this one. You always use this angle that you know, and you know you first get resultant. So you will do sine of 150 degrees. That is sine of theta all over the opposite line, which is 9, equals to sine beta all over the opposite length of sine beta is 4. So by the time you cross multiply, you have 4 sine 150 degrees is equals to 9 sine beta. 4 sine 150 is 2, so equals to 9 sine beta. So divide both sides by 9. So you now see that this is going to be 2 divided by 9 is 0.2222 equals to sine beta. So beta will simply be equals to sine inverse of 0.222. I see it. So whatever you get, beta will be equals to this answer in degrees. So that will be the angle you put here. So that is how you find direction when you use cosine rule. So you that have your calculator at home, punch it and put the answer. So this is how you go about finding angle between resultant and the vector. So notice this is the angle between this vector and the resultant. Here is the angle between this vector and the resultant. Very important. Whenever you use cosine rule or parallelogram, you're solving for parallelogram, this is how you find the direction. But assuming it's Pythagoras, you check my video. If you're assuming it's resolution of vector, you check my work on resolution of vector, so you find the answer. And remember, everything you do in physics must have proof. Just as we've gotten this answer now, assuming we take this thing now, assuming we take this question now, this 5 and 4, it's the angle given. For example, see what I mean. We are given this is the question. We are given a question, and the question we are given, we are told that we have 5 Newton, shall we? 5 this way, yes. Then as we are given 5, we are told that there's an angle here which starts from the origin, and that this angle that starts from the origin is 150 degrees. Then remember, initially we were told also that there's another angle here which is 30 degrees. Angles on a straight line. So you remember that it is this angle when you do 30 and 150. Yeah. So which means that, like we said, we will always ignore everything that happens on this side, on vertical or whatever. So we'll use the angle here that is from the horizontal, then remembering the signs. So I'll simply say this is 30 degrees. Even if this is entering here, this is 30 degrees. So that is what I will use. If I have that 30 degrees, I will now say if this is 30 degrees, this is 4 Newton. And notice that with what we've done so far, even when we did this here, 30 degrees, doing this here, and this, you see that this is 4, still entering this side of x, and this side of x is minus, this is plus, this is minus, this is plus, this is plus, this is minus. So let's just bring it out. We'll just use this to interpret this. If you like, don't go and watch my first video. You should not be saying he's making it confusing. Go and watch my first video, the one I said shortcut on Mmanu method 2, resolution of vectors. So if I redraw this very well, you see that this is 4 Newton, this is 5 Newton, and I'll be using the angle on the horizontal. I always abandon any angle here. So if you want to do this, you now say x, now say y. So then you now have this one, this 4 is on the negative x side. Let me just put it negative 4. On the y is not there. There's no 4 there, 0. Then this 5, I can take it to x, I can take it to y. And remember that once we are using this, x will always be on cos theta, while y will always be for sin theta. So towards the angle cos, away from them, so I'll say 5 cos 30 degrees and 5 sine 30 degrees. Then you need to remember something. This is in the second quadrant, and in the second quadrant we have this to be plus, we have this to be minus. Remember, it has nothing to do with 4, because 4 already has minus because it's on the side of x. See what I mean? Here is plus, which means that x here is plus, y here is plus. Here is plus minus, which means that here x is minus, y is plus. Here is minus, here is minus, which means that x here is minus, y here is minus. Here x is plus, y is minus. So if you look at that very well, you now see that on this side x should be minus, so I come and put minus here. Y should be plus, come and put plus. So it's different from when I have just this. For that one that has 4, this is minus x 4. Then y does not have it, so x minus 4. Y does not have it, 0. Alright. So I now go back to business. So I'll now say 5 cos 30 is 4.3301, but it's having minus, so it will be minus 4.3301. So 5 sine 30 is 2.5. So everything here is 2.5, and everything here is going to be minus 4 minus 4.3301, which is giving me with minus, okay, yes. So it will be minus, remember this is the value when you do this, so now I have minus 8.3301. Remember when you do this, 5 cos 30 give us minus 4.3. So I now have this on this. So once I've gotten x and y, is the same thing as saying I now have x to be minus 8.3301, then y to be 2.5, and r squared equals to x squared plus y squared minus 2xy cos 90, because this is at 90 degrees, and cos 90 is 0. 0 times 2xy negative. Anything times 0 is going to be off. So r squared is simply equals to x squared plus y squared, and r squared is going to be equals to, if you take the square root of both sides, this will cancel this. So r will be equals to square root of minus 8.3301 squared plus square root of 2.5 squared. So this is going to be minus square is going to be plus, so 8.3301 times 8.3301. This should give me that r is equals to square root of 69.3906 plus 2.5 times 2.5 should be around, okay, 2.5 times 2.5, that is, or more like saying 2.5 raised to power 2. Okay, that's 6.25. So if you do, so if you do 69.3906 plus 6.25, you have that r is equals to square root of 75.6406. So if you do square root of 75.6406, you have r to be equals to 8.6972, r to be approximately 9 in Newton. So you see, this same answer we have here, that r is 9, by using resolution of vectors, is the same answer we got when we did using parallelogram for the resultant. Remember that when we used parallelogram for the resultant, after solving everything we solved, we got r to be 9. Yes. So once you are correct, once you know what you are doing, if you use our principles, you see that your r from resolution of vector and that of r from parallelogram, so far as it's the same question you are solving, will always get the same thing. Thank you. Subscribe to the channel.